We were amidst this calculation, uh, we have substituted for, say, this one equal to the ground state energy of hydrogen in magnitude. Of course, in magnitude actually the energy is this amount with a minus sign, and we substitute A equal to h cross square by me square, where this is charge of electron E and it is not the velocity of light in free space as it might resemble in this, say, scanning. Anyway, pardon for my poor scanning quality using my mobile phone. So this term h cross by mca becomes h cross by mc into A is h cross square by me square. So h cross vanishes, one there remain in the denominator, m also vanishes. The quantity then becomes E square come to numerator divided by h cross c, that is nothing other than the fine structure constant alpha. So we substitute h cross by mca all square as a alpha square. Then this becomes, this term is magnitude of ground state energy of hydrogen, magnitude En0. This is alpha square, and there remain one n divided by n into the quantum number terms, j into j plus 1 minus l into l plus 1 minus 3 by 4 divided by l into l plus 1 into 2l plus 1. But we have already expressed the ground state energy of hydrogen in terms of the fine structure constant. This I think I have given you as an assignment earlier. So En was found to be minus alpha. Yeah, we have used this result while we talked about the relativistic correction also. En equal to minus alpha square mc square by 2n square. So we substitute En as, say, this quantity. Then this becomes modulus En equal to this quantity with a positive sign, of course. So this is alpha square into alpha square alpha raised to 4 mc, actually a c square is there, I have omitted it while writing it, sorry. Alpha raised to 4 mc square divided by 2 is there, this one, into n square into n, make it n cube into j plus 1 minus l into l plus 1 minus 3 by 4 divided by l into l plus 1 into 2l plus 1. So this is the spin-orbit coupling energy expressed in terms of the fine structure constant alpha. Here also you could see that the spin-orbit coupling energy, as we have seen earlier in the case of the relativistic correction energy, is of the order of alpha raised to 4, whereas the ground state energy is of the order of alpha square. So this is still lesser in terms or comparing with the magnitude of the ground state energy of hydrogen. Recall, alpha is in fact a quantity less than 1, as alpha is found to be approximately equal to 1 divided by 137. So it is nearly 1 by 100th or 100 times lesser than 1. Now we will evaluate the fine structure energy in hydrogen. As we have seen earlier while we started about fine structure, it is the combination of the correction in energy arising from spin-orbit coupling and relativistic correction. We have evaluated these two terms, so we just combine them. Then the fine structure energy EFS is equal to ESO, the spin-orbit coupling energy plus relativistic correction, and this is the spin-orbit coupling energy plus relativistic correction that was found to be minus alpha raised to 4 mc square by 8n raised to 4 into 8n by 2l plus 1 minus 3. So let me take this quantity as a common parameter, alpha raised to 4 mc square by 8n raised to 4. So this quantity will be remaining in the second term. But in this term I have only alpha raised to 4 mc square by 2n cube. So I'll have to multiply the denominator by 4n, so that I will have to multiply the numerator or all the three quantities in the numerator also by means of 4n, so that I could take this quantity as a common factor. Let me take it out. Then this becomes alpha raised to 4 mc square by 8n raised to 4 into first terminal ന്യൂമറേറ്ററിലുള്ള എല്ലാ ടേമിനെയും 4n കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്തു. 4n ഈസ് ഹിയർ, 4n ഈസ് ഹിയർ. Minus 3 by 4 into 4n make it say minus 3n. And also we know that J, the total angular momentum quantum number, is the sum of the orbital angular momentum quantum number and spin angular momentum quantum number. But S can have only two values, plus half or minus half. So evidently J equal to L plus or minus half. That means you can have two different choices for J. So we'll have to evaluate this quantity of fine structure correction energy for both J equal to L plus half and J equal to L minus half. For the time being, I will solve here this value for J equal to L plus half. The remaining for J equal to L minus half, you do it as a homework. Both these results are exactly identical. You will get the same result for J equal to L minus half also. This is only a mathematical work that we have to follow. When J equal to L plus half, L equal to then J minus half. Put these values here. We make it say alpha raised to 4 mc square by 8n raised to 4 as a common factor, which is taken out. So 4n കൊണ്ട് ഫസ്റ്റ് ടേമിലെ ന്യൂമറേറ്ററിലുള്ള എല്ലാ ടേമിനെ മൾട്ടിപ്ലൈ ചെയ്തു. 4n J into J plus 1 minus L into L plus 1 was there. You substitute L equal to J minus half. Then L means J minus half into L plus 1 means J minus half plus 1. That is J plus half into 4n denominator adjust ചെയ്യാൻ വെച്ച quantity. Minus 3 by 4 into 4n make it say 3n divided by the denominator was L into L plus 1 into 2L plus 1. L into L plus 1 is J minus half into J plus half. We have written it here. 2L plus 1 means 2 into J minus half plus 1. 2 into J minus half plus 1. That is 2J minus 1 plus 1. Make it say 2J. Minus the second term, we have taken this quantity as common factor. So what remains is 8n by 2L plus 1. 2L plus 1 is 2J plus 3. So we can cancel 2 and 8 here. This term is there. Alpha raised to 4 mc square by 8n raised to 4. We open this bracket 4nj square plus 4nj minus, this is of the form a minus b into a plus b. Make it say j square minus 1 by 4 into 4n. That is minus j square into 4n plus 1 by 4 into 4n, make it say plus n minus 3n divided by 2j into j plus half into j minus half. We cancel 2 here, make it say 4n by j plus 3. Alpha raised to 4 mc square by 8n raised to 4, this term is there. I have mistaken for say cancelling it. Anyway, 4nj square vanishes. 4nj plus n minus 3n. Make it say 4nj minus 2n. Divided by 2j into j plus half into j minus half. Minus 4n by j plus 3. That's equal to this quantity follows. 4n into, let me take 4n as a common factor from the numerator. 4n into j minus half, so that I could cancel j minus half in the numerator and denominator. Minus 4n by j plus 3. That is 2 vanishes, 2n by j into j plus half minus 4n by j plus 3. Or this is 3 plus, make this j into j plus half as an LCM or say common denominator. So that I will have to multiply this term by means of j plus half. Then this becomes 2n minus 4n into j plus half. Minus 4n into j plus half. That's equal to 3. 2n minus 4nj minus 4n into half is minus 2n. So this term becomes 2n and minus 2n vanishes. Minus 4nj divided by j into j plus half. J vanishes, make it say 4n by j plus half. For j equal to minus half, L minus half also you will get exactly this result. So this value give you the fine structure energy as long as hydrogen is concerned. So the fine structure energy is alpha raised to 4 mc square by 8n raised to 4 into 3 minus 4n by j plus half. Let me multiply this by means of a minus into minus. So this is alpha square by 4n square. we will arrange it like this: minus alpha square mc square by 2n square. The overall quantity is exactly same as this one, and this minus will be absorbing here in the next step. This is now alpha square. This quantity is, say, with a minus sign, is exactly the ground state energy of hydrogen, not the modulus value, but exactly the ground state energy of hydrogen, minus 13.6 by n square, or say minus 13.6 electron volt. So this is not the ground state energy of hydrogen atom in the nth quantum state. If it is a ground state, then this n should be equal to 1. So this is alpha square En0 divided by 4n square into this quantity get reversed. 3 minus 4n by j plus half becomes 4n by j plus half minus 3. Or with this fine structure correction, the energy of hydrogen atom in any particular quantum state is Enj equal to En0 plus alpha square En0 by 4n square into 4n by j plus half minus 3. That is, En0 is taken as a common factor into 1 plus alpha square by 4n square into 4n by j plus half minus 3. So with this fine structure correction, energy of hydrogen atom is raised by an amount which is of the order of, say, alpha square. So with that, we come to an end for this discussion on fine structure in hydrogen atom, and with that we end this module. I have already told you about the various possible questions from this module. You can have one compulsory essay question and 1 or 2 problems. Of course, 2 or 3 short answers also will be asked from this module, and this module give you a foundation for module number 3 also, that is about the time dependent perturbation theory, where here we have formulated the concept of the time independent perturbation theory. So learn very well. This is a very important module as long as your paper Quantum Mechanics 2 is concerned. With that, we come to an end for this discussion. From the next class onwards, we will move to the next module. That's about a variational method. Okay.